a doubt, one of the neatest things about nature is freshwater lakes. That's why me and Jess created Lake Talks, so everybody can know about how neat lakes are, except for me and Jess just knowing it. How neat is that? Today we have a special guest, Angela Walleye. She knows about how neat lakes are. She's a lake expert.
My name is Angela Walleye, and today I'm going to help Meg with her lake talks.
Lakes fall under the category of freshwater biomes, which cover 1/5 of the Earth and are vital to our survival. Humans and animals gain more than half of their drinking water from these sources. Freshwater lakes are found across the entire globe. Common types of lakes include stream or river-fed, glacial, which are created by melting glaciers, and artificial, which can be formed by the addition of a dam from old mines or quarries which have filled in after use. Another more unique lake type, mainly found in Antarctica, is a subglacial lake, which is a lake permanently covered by ice. Freshwater lakes can support large communities of plants and animals due to their less than 1% salt concentration.
That's pretty neat.
Today, Meg is focusing her lake talks on Lake Erie, which is the shallowest, warmest, and most biologically productive of all the Great Lakes. Lake Erie is home to 130 fish species, which includes at least 18 non-native. 10 species of the native fish have been extirpated from Lake Erie. In this food web and chart, you can see the more dominant species that reside in Lake Erie. The main categories include sea lamprey, piscivores, which are fish eaters, forage fish, macroinvertebrates, zooplankton, and phytoplankton. The climate of Lake Erie's water is 71 degrees Fahrenheit on the top and about 39 degrees Fahrenheit on the bottom. The surface temperature drops during fall and winter, which can lead to freezing of the surface waters. The water will begin to warm again in the spring and summer. The fluctuation in temperatures can be further explained as the stratification of the lake. Alright, Meg, let's test your knowledge. Diagram the water stratification of Lake Erie. Environmental factors such as pH, dissolved oxygen, nutrient concentrations, and light availability are affected by lake stratification. Thermal differences are what cause a lake to stratify into a warm upper layer, the epilimnion, a cool lower layer, the thermocline, and the deepest, coldest layer, the hypolimnion. The hypolimnion forms due to cooler water having a higher density than warmer water. These differences cause completely different habitats to exist throughout a lake. The epilimnion has the highest dissolved oxygen and light availability, but is low on nutrients. Aerobic microbes are most abundant here. The thermocline has less oxygen and light, but more nutrients, creating a habitat for, Meg, that's supposed to be facultative anaerobes.
Gee, dang it.
That's right, you're doing a pretty good job. Anyway, the cold hypolimnion contains almost no oxygen or light, however it contains abundant nutrients. Anaerobes thrive in these conditions because of their metabolisms, they are unable to take full advantage of the nutrients. When the seasons change, it results in a process called turnover in Lake Erie. As you can see, the turnover process causes the separate layers to converge into one, and the nutrients that were on the bottom of Lake Erie are brought to the surface. As the surface gets colder, it becomes more dense and begins to sink. The less oxygenated water at the bottom starts to rise and now becomes oxygen-rich, which allows for species to migrate throughout the different depths of the lake.
How neat is this?
Today I'm going to enlighten you about the toxic algal blooms that Lake Erie faces each year. The main concern is the increase in the cyanobacteria microcystis that produces a hepatotoxin microcystin when they die. The toxin causes skin rashes and burns and nausea, vomiting, and liver damage if ingested. In addition, it may be carcinogenic and has been known to kill dogs and livestock. When boiling the water, the toxin can still persist because it becomes concentrated. Research has shown that the removal of piscivorous predators like bass, pike, and walleye causes a trophic cascade by increasing zooplanktivores, which in turn reduce grazing herbivores and allow algae to flourish. Algal blooms are a threat to aquatic ecosystems. In Lake Erie, they decrease the acidity of the lake water, which can irritate fish gills. In addition, when the algae die and sink to the bottom, the decomposition process uses up so much oxygen that nothing else can live in the hypolimnion, creating a dead zone. The sources of the damaging blooms are nitrogen and phosphorus, but mainly phosphorus. Agriculture practices and municipal water waste treatment plants increase phosphorus content in the lake. Dissolved reactive phosphorus, or DRP, which is used in fertilizers, drives algal blooms because it is more readily available to use than particulate phosphorus. Zebra mussels also enhance algal blooms because they are filter feeders and in turn increase water clarity and allow sunlight to penetrate deeper. In response to the blooms, the U.S. Agriculture Department is awarding $5 million to help farmers put an end to the algal blooms by learning how to add gypsum to soil, implement conservation tillage or no-till systems on crop fields, install agricultural drainage water management systems, and implement nutrient management plans.
I'm Meg. And I'm Jess. And we want to thank you for watching Lake Talks.